All right, so the perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from each endpoint of the segment. So what it's saying is this point X is on the perpendicular bisector for the line AB. So X must be an equal distance from A and B. The converse says if a point is equidistant from the endpoints, so if we know that X is an equal distance, which is what these congruent markings mean, then it must be on the perpendicular bisector. So that means that this would be a right angle and that AY and YB would be congruent. So hopefully you can see the difference between those two. They're just going in the opposite order as to what you know. With the perpendicular bisector theorem, it says if I have a point X that is on the perpendicular bisector, so notice I already knew that it was this segment was or line was perpendicular to AB and it was cutting AB in half. If you know that, then you can add into that fact that that point X must be an equal distance from A as it is from B. So the distance from A to X and the distance from A to B are congruent. The converse goes in the opposite order as far as what you know. The converse says, let's pretend you know that you have a point on a line and it's an equal distance from the two endpoints of that line segment. If that is the case, then that line that the point is on is the perpendicular bisector. It cuts the segment in half and forms a right angle.